than a comparison of two numbers by division. A ratio is a comparison of two numbers by division. And you're going to notice that there are three ways I have up there that you can in fact write a ratio. Okay? The first way is we can actually use words and we just do x to y. The second way is instead of doing the word 2, we do a colon. So we just do x colon y. And then the final way is a fraction, because a ratio is nothing more than a fraction, x over y. So those are the three ways that we can write a ratio. Now, mainly today what we're going to do is we're going to talk a lot about proportions, because proportions are a way that we can solve equations. So far in this chapter we've talked about solving equations. We've solved one step, we've solved multiple step equations, we've solved equations with variables on both sides. Now we're going to solve equations using proportions, and I'll be honest with you, these are actually my favorite way to solve equations. Okay? And so a proportion is nothing more than an equation stating that two ratios are equal. Okay, so a proportion is an equation stating that two ratios are equal. So now what we're going to do is we're going to look at some ratios here. And if you look in the very first problem here, it says determine whether each pair of ratios are equivalent. Write yes or no. Now I like to do this problem a little different, and the reason why I like to do it a little different is because I like to do it the same way that I'm going to solve the proportions. Okay. And so that way we kind of do the same thing all today. And so in order to determine whether they're equivalent, I'm going to start down here, and I'm always going to start with the bottom right. And I'm going to go ahead and do this. I'm going to take the bottom right times the top left. So I'm going to take 24 times 2, and I'm going to write my answer right down below. What is 24 times 2? 48. And we actually have a special name for these, and we'll talk about that in a little bit on the next few slides. Now what I'm going to do is I'm going to start at the bottom left. So basically what I'm going to do is I'm going to kind of make a cross. And some of you might think this is real similar to cross multiplication, and it is. So I'm going to take 3 times 16, and what do I get there? What is 3 times 16? Close. 48. Okay. Now what I'm going to do is I'm going to compare those two numbers. So are these two ratios equivalent? And the answer is yes. They will be equivalent if those two numbers match. If they don't match, they're not equivalent. Yeah? You could. The problem is what happens if you get to problems on your homework and they aren't fractions that you can reduce like that. Okay. You could on that one, yes. But what I'm saying is when you get to your homework, and you'll see on some of these we'll actually have decimals involved, you're better to kind of do this because this is something you're going to be doing all today. So let's go ahead and have you try. Okay, are those two equivalent, yes or no? So we have 6/10 and 2/5. No, they are not. You should have ended up getting 30 and 20 when you multiplied them out, correct? So let's go ahead and look at another one. 1/6 and 5/30. Are those equivalent, yes or no? The answer is yes. Nice job. Whoa. For some reason that wrote there. And so now we're going to talk about how you can solve equations using proportions. And so first of all, we're just going to put some names to some of the things we've been doing. Those first two things we were multiplying, we call those the means. The second two things we were multiplying, we call those the extremes. And then we were actually finding the cross products. Now the reason why we didn't actually put the names to them then is because I didn't put an equal to sign between those two ratios. I just had a comma, if you remember. And so technically, we don't name those things until there is an equal to sign. Okay, so we have the means, which are A and D. We have the extremes, which are B and C, and then we have the cross product, which is what we actually found. A times D and B times C. Now the nice thing about this is they actually tell us that if that proportion exists, if A over B equals C over D, then A times D has to equal B times C. So that's what we're going to be doing today, solving proportions. So let's go ahead and look at an example. And notice this one, it says use cross products to determine whether each pair of ratios forms a proportion. So a lot of this is once again the same thing we just got done looking at. So what I'm going to do is I'm going to do the cross products. So I'm going to start, remember I always start in the bottom right, and I'm going to multiply to the top left. So 14 times 2, what is 14 times 2? 28. Now what I'm going to do is I'm going to go on the other. I'm going to multiply the extremes. So 8 times 3.5, and you might not be able to do that in your head. So we just need to come over here and take 3.5 times 8. If I take 5 times 8, I get 40. Carry my 4. 8 times 3 is 24. Add another 4, you get 28. I count decimals, I have 1. So in fact, 8 times 3.5 is 28. Notice they do equal each other. So does it form a proportion, yes or no? Yes. What? It says to determine whether each pair of ratios forms a proportion. So you're answering yes or no on this one.
Well, if it already has an equal sign, then it isn't.
No, it's not on these. They put that there, and they want you to determine yes or no. So I want you to go ahead and find this one for me. Okay. Does that form a proportion, yes or no? And the answer is no. You should have gotten the product of your means to be 0.6, and you should have gotten the product of your extremes to be 0.75. Let's look at another one. Okay, 0.2 over 1.8 equals 1 over 0.9. The answer is no here. The reason here is decimals. 0.9 times 0.2 should be 0.18. Okay? Over here, 1.8 times 1 should be 1.8. So that is why they are not equivalent. Okay? Okay, so now we're going to solve the proportions, and that's how we're going to finish our final few problems. And then I think we have a word problem as well. So we have x over 10 equals 3 over 5. So we're going to do this exact same as what we did the previous problems. So I'm going to take 5 times x, and what do you get? 5x. Equals, on the right side, I'm going to take 10 times 3, and what do I get? 30. So this is a basic one-step equation that we had probably about last week. Okay, so how do I solve that then? Divide by 5. Very good, because it's 5 times x. So I'm going to take 30 divided by 5, and I get what for my answer? 6. Now notice it just says, if necessary, round to the nearest hundredth. So if you want to get something correct, but I would prefer that you do those answer actually in fraction form. Okay, so let's look at this one, because this one is a little bit different. Yes?
For that one, didn't you just multiply the
Mm-hmm. But this one doesn't work. That's why I don't show you that. Okay. Okay, so now we're going to start by taking 7 times x minus 2, and that's going to equal 2 times 14. So really what ends up happening is that's what I'm going to get, right? Because I'm multiplying the 7 times the x minus 2, and I'm getting 7 times x minus 2, and then I'm multiplying 14 by 2. So now in order to solve this, what do you have to do with that 7? Distribute. And so really I get what? 7x minus 14, and what will that equal? That'll equal 28. Okay? So then now how do you solve that? Add 14 to both sides. So if I add 14 to both sides, on the left side you are left with 7x. On the right side, what is 28 plus 14? 42. So now to solve, what am I going to do? Divide by 7. So if I divide both sides by 7, I get x to equal 6. But notice when you have a quantity, you need to make sure that you take that whole quantity times that number. All right, I want you to try this one with the quantity. Okay, x plus 4 over 12 equals 3 over 8. X plus 4 over 12 equals 3 over 8. Now this one, you can go ahead and answer it as a decimal. Go ahead and answer this as a decimal. Okay, so let's see what you ended up getting. Answer should be 0.5. Now how we got that is we're going to take 8 times x plus 4. And that's going to equal 3 times 12, which 3 times 12 is 36. So if you distribute, you should get 8x plus 32 equals 36. Subtract 32 from both sides and you end up getting 8x equals 4. Divide by 8, you should get x equals 4 divided by 8, which is 1/2, which is 0.5. Okay? All right, let's look at what this says. It says it takes 7 minutes for Izzy to walk around the gym track. At this rate, how many times can she walk around the track in a half hour? So let's think about that. So first of all, we're talking about laps, right? And we're also talking about time. So this is what my proportion is going to look like. I'm just going to put laps divided by time. So let's start with the first sentence. The first sentence tells me that Izzy can walk how many laps? 1 lap in how many minutes? 7 minutes. Now, one of the important things is that you need to keep your labels consistent. So then it asks me how many times can she walk around the track in a half hour. So would you understand that I'm trying to find L, the number of laps? Okay, and in a half hour, now remember that first one was 7 minutes. So what am I going to put now for my denominator here? 30. So it's important that you understand that your labels need to be the same. And if not, you need to go ahead and change them so that they are. So let's go ahead and multiply. So here I have 1 times 30, which is 30. Very good. Equals this diagonal, which is 7L. So now I need to solve this. So how do you solve it? Divide by 7. So I need to think about what type of answer I'm going to get here. And so how many laps could she walk in 30 minutes if each one takes 7 minutes? Now this one you're obviously going to get a decimal, or you could get a fraction, which is going to be 4 2/7. So how many laps could she walk? 4 laps. It didn't say how many partial laps, it just said how many laps. So what you're going to do is use the nearest whole number. Now one of the things with these is they don't round up. So if it would have been like 4 6/7, you wouldn't have rounded up to 5. So let's see what we have. On a model airplane, and this is where proportions are used a lot, the scale is 5 centimeters to 2 meters. So this is what we're going to use. Centimeters over meters. So you know that you have 5 over 2. That's your very first statement. If the model's wingspan is 28.5 centimeters, what is the actual wingspan? So I'm going to go ahead and write my proportion. Where does the 28.5 go? Top or bottom? Top. Okay, so now I need to go ahead and multiply. So I start by multiplying my means. What do I get here? 5m, good. Equals, multiply my extremes, and what do I get there? 57. Good. So to solve this, what are you going to do? Divide by 5. So I get m to equal 11.4. Label will be meters. Okay. Questions? Like proportions? Like I said, they're always my favorite. So this is what I need you to do for me for tomorrow. I need you to do page 115, 10 through 42, the evens. Okay, page 115, 10 through 42, the evens.